Good morning, students. Today you are going to learn about templates in C++. Template is simple and yet very powerful tool in C++. Templates are the foundation of generic programming, which involves writing code in a way that is independent of any particular type. A template is a blueprint or formula for creating generic class or a function. Okay, so here you have to think about what is generic programming and what is a blueprint or a template. Okay, generic programming means it allows the user or the programmer to write an algorithm which can fit for any type of data. Means once you write an algorithm, it can fit into any type of data. Okay, and here a template is a blueprint or a formula for creating a generic class. Means here using templates you are going to write a function block which can accommodate any data type as arguments. Okay, here you have two types of templates, function templates and class templates. So today we are going to discuss about only function templates, and function templates are special functions that can operate with generic types. Generic types here means these are the types which do not have any predefined data type. Okay, so this allows us to create a function template whose functionality can be adapted to more than one type or class without repeating the entire code. So here, once you write a function template, you can use it for many times and no need to rewrite for every data type. You can use the function template for any kind of data type. The simple idea is to pass the data type as a parameter so that we don't need to write the same code for different data types. Usually in function overloading, we pass data values as arguments, but here in function templates, you are going to pass the data type itself. Let me give an example here. There is here function overloading code and function template code. So here I have defined a function named add for different data types. For integer data type, I have one function. For float data type, I have one more add function, and for double, I have one more add function. Okay, so instead repeatedly writing the same function for three different data types, here in the function template, I can define I can define one template. Here, this is how I can define a template. Template is a keyword, and in the angular brackets, you can write the type name. Here, type name is also the keyword, and here T is the placeholder. Okay, so here in T, you can mention any type of data. And see here, I am defining the function add as T add tx and ty. Here, x and y are the actual formal arguments, and here t indicates the data type. It could be integer, float, or double, or char, any kind of data type. So here I'm avoiding, here I have defined three add functions. Instead, using the function def template, here I am writing only one add function. And in the main, here when you see in the function overloading, here we have add 5 comma 4. So when I call this function add with passing 5 and 4 integer values, so this integer function add is going to be invoked. And here second time I have passed two float values, so this float add function definition is going to be invoked. And here I have passed some double float values, and this double add function is going to be invoked. And coming to the function template, as I didn't mention the data type, here in the main function, I'm calling add, and in the angular brackets, I'm going to pass the data type here and data type, and this here int, this int will be going to fill in this placeholder t. And when I pass the actual values 3 comma 7, so as this t is replaced by int, this function definition becomes int add int x comma int y. And here in the second time call, I'm passing float as a placeholder. So this float will be replaced in t, and when I pass the float two float values, these will be moved to x and y. So this is how, using the function template, you can avoid redundancy of function definition usually we do in function overloading. Let me explain very clearly with a program. See, so here this is int add, float add and double add. So these are the three function definitions, means this is the function overload. I'm going to overload the function add with different data types. For integer I have one definition, for float data type I have one more definition, and for double data type I have one more definition. And in the main I'm going to call a function addition of two integers 3 and 4 is add 3 comma 4. So with this particular int add will be called, and if I run I get the value 7. And here if I pass two double values, so here we are going to, this is function overloading, and let me replace with a function template. So I am going to keep everything in comments, so because I don't want to demonstrate function overloading, here I am going to write a template with by using the template keyword, template type name is here, template and type name or the two keywords. You can keep a space or you can avoid the space. Type name, and I have to mention a placeholder t. Here it is t, and t space function name, here it is add t space x, and xy are the two arguments. And here I'm going to return the value of x plus y. And in the main function, what I'm going to do is, so xy, and in main I will call the function add, and also in the angular brackets I have to mention the data type. Here int will be substituted in t, and when I, with this 3 and 4, the function template is going to substitute int function. T means int add, and here int x comma int y. So if I run, I'll get the output 7. Okay. So this is what is function templates. So here in the program, instead of using the same function name repeatedly for each data type, here I am writing one template for, I have defined one template, and I can use it for any kind of data type. It could be int, or it could be float, or it could be double. See here, if I use the float, so here I'm using addition of two float variables 3.4 and 4.2 is here add float. In the angular brackets I have mentioned as float. So this float will be substituted in the placeholder t, and here the function definition becomes float add float x comma float y. Okay, so this is what exactly function templates are. Thank you, students.